So with my pleasure to introduce today's presenter, Ryan Sharpston. Ryan has been a senior technical instructor employed by Global Knowledge since 2005. Ryan joined Global Knowledge after 20 years of field installation and maintenance experience, working with a wide array of communication and networking systems. Currently, Ryan trains Global Knowledge students worldwide on network security and telecom platforms. Courses include Palo Alto Networks, Sonic Wall, and Avaya Technologies. He also serves as the lead subject matter expert for GK integration and lab design for new course and environment updates. Ryan lives in Dallas, Texas. So with all that, Ryan, I'm turning it over to you.
And thank you very much. Thank you. I hope you all can hear me. And thank you for taking a little time out of your day to join us. This is a very popular webinar subject, so I'm happy to be here with you. As a matter of fact, I'm on my lunch break from delivering this very training to 20 students. So it's a popular course, and I hope you find some information within this that is going to maybe spark an interest for you and your organization regarding security. Today's networks obviously look very different. Almost overnight, we became a remote workforce. And so that is not something new to myself. Being an instructor, I've worked from home forever. But over the course of the last few months, as you saw, many organizations on a dime had to switch and be able to support and secure remote workers. And so what we're talking about today is a huge part in that. And as a matter of fact, there's several very good resources that I've seen, even commercials on channels that I watch, related to the large role Palo Alto Networks is playing in this giant change in how America and the world is doing business and how we're commuting and telecommuting. So we're talking today about a very specific component. This is actually a component, a piece out of the training course. And we call this training course the Threat Prevention and Firewall Essentials. And we talk a little bit about the PAN-OS. That's the operating system underneath the hood of a Palo Alto Networks firewall device. So certainly there's a lot of information here, and if you're interested, we'd certainly love to see you in the training class and go a lot deeper into some of these topics. Certainly what you see here is an introductory slide, and I'm going to go ahead and advance through. The operating system itself is so unique. We want to talk about something called the single pass parallel process. And the reason it's so important in today's network security is its performance advantage over other systems in the way they function in multiple analyses techniques being applied. It tends to create a less snappy response involving more latency. So built into our operating system, the single pass parallel process feeds into what we call the zero trust alignment. So let's talk a little about the PAN-OS approach. Palo Alto Networks is certainly gaining lots of momentum. As you can see, over and over in networking across the world, I see a lot of transition from what I'll call Firewall X, and it could be at any number of vendors. But I entertain and train a lot of non-Palo Alto Networks firewall administrators because there's a huge push to the PAN-OS platform and its family of products. So what's the big advantage? Well, if you look right here at this slide, the Cyber-Attack Lifecycle is known to have stages. I compare this many times to if there's a break-in in my neighborhood, I often sit and wonder, was there some stakeout going on? How did someone know that this house was A, a target, B, available, and why was it chosen? So you can see and compare that to our networks. If there's a breach, if there's a problem or an attack, if you will, there are many different stages probably where a nice feature configuration would have been effective. Maybe it was during the reconnaissance. Someone's doing a SYN flood or a recon, a port scan on the outside interface of my network firewall. Well, certainly I've got features that can identify, we call zone protection and DOS type facilitation. But that's just one element. You see all these other different stages, and we have the ability with our robust feature set to impact and control that attack at any point. Now, in our training that I'm running this week, and really the operating system you're learning about, lives right down here in the network security triangle or rectangle here. This firewall is a cornerstone. But if you look at this slide, it is certainly not working alone. There is endpoint protection available from Palo Alto Networks. It is a completely separate element, but works in conjunction, if you will, with the firewall's rules and controls. There's also a huge push in Palo Alto Networks with cloud networking, cloud security. And so, again, a completely different but involved and integratable piece of the overall Palo Alto Networks platform. From my perspective, the main thing I tell folks here is my firewall is down here playing a very important role. It's the enforcer, but it is gaining intelligence from cloud-based systems where a lot of its enforcement information comes from. So Palo Alto Networks regularly publishes new threat signatures. Maybe there was a new virus signature, a new attack file found in another part of the world. So that could be one of these new signatures created to update all of our firewalls across the enterprise. Another thing that they constantly update is application signatures. We can tell in the PAN firewall, we can tell the difference between a Facebook communication path stream and a YouTube communication stream. We call those app ID signatures, and they are created and managed and then updated into the firewall. We can even utilize our own intelligence and coding expertise and third-party companies. I showed the group yesterday how to create our own custom signature, and it's just a pattern that we look for in a header in part of a communication. So, for instance, an HTTP communication. That's what we call apps. And those can come from any number of sources. That's what makes the PAN-OS so flexible. And so on the integration level here, this is a framework and logging service to incorporate worldwide communication between, of course, all of these intelligence systems and our what I'll call our soldiers on the ground, our security personnel in the network and on the machines or in the cloud. So as you can see, it's a huge, important family. Another element of this family of PAN-OS components and providing or pitching into the security overall, Panorama is another completely different element. It's designed as a central management and reporting function. It's a physical box or it could be a VM. What it can do is manage 500 firewalls from a central console. So I like to train people on a single firewall and learn the menus, and then we move and transition into Panorama, where I can make those same changes and push them out instead of one firewall to 500 firewalls in one simple transaction. So Panorama is another element on the team. Aperture, this is a software as a service security mechanism, another intelligence service, but it focuses on your Salesforce applications, your whatever cloud-based or software as a service functionality that may be a part of your user community. We just finished this discussion in the class, as a matter of fact. Global Protect is a very powerful client VPN software option. So if you have a mobile workforce like most of the world now, if they need secure connectivity back into the network, so that the firewall can protect them just as if they were still sitting in their cubicle. Global Protect extends that security to the other side of the town, the other side of the state or country, even across the world. So Global Protect is a hugely popular component, and again, it's a client VPN related element. Autofocus is another threat intelligence cloud. One of the great suggested attributes of PAN, the Palo Alto Networks engineers, they share information. So if somebody discovers a threat, in South America, as far as networks, well, shouldn't that be known to the entire world? And so autofocus is a really helpful intelligence database that can help us focus on recurring threats. Another final, I call it an external mechanism, mind meld. We can build on the firewalls what we call external dynamic lists. So I can have a firewall control my user traffic. If anyone tries to make a DNS request to a known, maybe they've got spyware on their machine, they don't know it, and their machine is calling out to a known .ru bot controller. A spyware is in action. So mind meld is one of those lists, and we can point at a URL, basically a file out there in the cloud, and when the user's machine attempts to contact that botnet or that the bot controller, mind meld has that entry on a list, and our firewall can react to that. So an extraordinary set of capabilities, and almost everything Palo Alto Networks offers now is available in the cloud. Our architecture is really where the tires touch the road, okay? If you hear people discuss the firewall technology of Palo Alto Networks, you're undoubtedly going to hear the single pass parallel process. So in the past, many UTM devices have had to bounce a packet from one service to another over the network. And it's like going through a car wash where they wash your windshield. Then you go through another car wash where they wash the tires. And so instead of providing all the service and analysis in one pass, there is an extra latency between those alternating analysis techniques, from the networking module over to the IPS module to the antivirus module. And with the delay in between each transfer and each process, we just introduce more latency. And I think everybody agrees. In today's networks, we need a lot of response. We need a lot of high availability for our resources. That's why the single pass, for me, I always compare it to a race car pit crew. How crazy would it be if I pulled my race car into the pit and I'm in the lead and I said, just give me your right front tire and then I'll let me go. When I come back around, I'll pull back in here and you can give me some gas. Well, that's ridiculous. So our single pass process functions just like a pit crew does, like an army of systems, an army of software and hardware processes that apply the analysis techniques in the single stop, in the single buffer of that packet. Based on our rules, we have identification of the application itself. We can also tie that traffic to a specific originating user or group. We can also examine at the same time, while we're looking at layer 7 in the payload, while we're looking for app ID matches, we can also spot viruses or confidential data, etc. So it's a single process that we call the single pass parallel process. And you can see here the elements that apply those analysis techniques. It's certainly very simplified here, but if you want more information, I believe the Palo Alto Networks presence is super effective at illustrating some of these topics for those that might be considering PAN-OS as an alternative network security solution. Actually, under the hood, we have what we call two organized planes. One is in charge and responsible. I call this the brain. It's involved and responsible for logging. which the Palo Alto Networks logging is the best I've ever seen, and that's just a side note from an administrator. I just love the way our logs are laid out. They're so easy and user-friendly to aggregate that information and utilize it. The reports, insanely flexible. But all of that, including making changes to the configuration itself, that's the responsibility of the brain, the control plane. It has its own memory and processing power dedicated to those functions. Now, who passes the traffic? Who takes a packet off the network and processes it and sends it back out in the network? Well, that's the data plane. And the data plane consists of several elements that, again, are software sometimes. In some models, they may be an ASIC chip or an FPGA. So it could be a physical component. It could be software. But here's what they're responsible for. The packet comes off the wire. You've got your normal networking. What's the source and destination? And so your MACs and your routing and your NATing, all a part of the network process in what we call a lookup. And once that is designated as a communication that should continue, then the security processor takes over, and that's where we actually enforce these rules. That's where we identify, can we tell the application at layer 7? Is there any encryption? Are we matching any specific rule? And if so, we will apply that enforcement. And finally, we have an area of memory known as the signature matching, credit card numbers, spyware signatures, social security numbers. These are all considered specific patterns, and we match those in certain behaviors and allow or control certain traffic based on the signatures we're able to detect inside that communication. So again, a simplified look, but you can tell we do it faster. Okay, now that's a very non-technical explanation. We are much more high performance than a lot of other security systems. And that's a result of the single pass process. In an open network, a lot of times traffic is assumed. There are zones and users and computers assumed to be trusted. We enforce a zero trust approach. Now, what does that mean? I've got a firewall at my perimeter. Isn't that good enough? Well, oftentimes people forget and overlook east-west traffic. We all talk about north-south traffic entering email coming into our network. That's a huge vulnerability. Users clicking on a suspect email. Files going out of our network. We all consider that a candidate for analysis. Oftentimes, users forget about traffic traversing from one data center VM farm, server farm, to another part of that same data center. This is what we refer to as east-west. And many times, we just consider that. There's no reason we should analyze that. But in a zero trust approach, we take a different approach altogether. Of course, the perimeter is always going to be a cornerstone of our security. However, what about your mobile users? What about your smaller branch offices? What about software services that we use every day, all day long? Well, now look at what our zero trust model incorporates. Your mobile endpoints, your mobile users, they can work from home, work from the road because of Global Protect. And that's a VPN functionality. It's like a 10,000-mile long patch cable. And they're plugged into the firewall, and the rules and the controls treat that user exactly as if they were sitting inside the network. So mobile endpoints, check. How about the branch office? Well, of course, you've heard of site-to-site VPN. We always tie branch offices and the resources behind them to the corporate data center with a very easy route-based IPsec site-to-site VPN. So now users are able to communicate securely between the branch office and the headquarters. Go a step further and look in this data center. We've even embedded a data center layer of security here behind the perimeter firewall. And then finally, what I think is very important to understand, if you've got a lot of VM server farms or a large VM presence, we could just as easily drop a VM firewall into that element, into that object or that segment of your network, and we should then be able to examine that traffic, because batch files, file updates, all these things could indeed present some vulnerabilities. So that's the difference in a kind of an old style view and what we call a zero trust. Analyze everything. Now, to come back around to that first topic, the feature set you see listed here, these are all of the built-in protection capabilities of PAN-OS. So App ID, one of the biggest things I'll do with that is I'm not going to allow you to use a BitTorrent program to download, 9 years worth of music. So high-risk applications like BitTorrent or other very high-risky applications, I'll just create an App ID approach that won't allow them. Okay? I can also use App ID to control things like command and control and anything that would try to exfiltrate or infiltrate through our network. So everything here has a place and a reason that it is effective against some stage of the attack lifecycle. And you'll learn about all of these in the Essentials PAN-OS training. It's very exciting. If you're interested in a larger organization, or maybe you've got a startup client out there you're interested, our family of products here cover the entire spectrum. We've got the little Soho type, small office, home office, our lab devices all the way up through the mid-range. And this PA7000 series is just a beast of a security component for extraordinarily large enterprises. Below here, these are not firewalls. They play a different role. As I mentioned, these can play the role of that centralized management. And if you use Panorama, you can simplify the administration over hundreds and thousands of individual firewalls. So these devices, again, play a different role. Now, these are all physical appliances. Of course, you know that today's networks, virtual appliances and virtual machines are a huge player. So with the series we have here, scaling from the little small device all the way up through our 700, you can see the throughput capabilities appropriated for each one of these. And of course, the speeds and feeds, I call them, depending on how you've configured. If I have no in-depth packet analysis on, well, it's not very secure, but it's also going to be a little more snappy response time and throughput. If you enable these deep dive packet analysis, it's always going to have an impact to a degree on the throughput of a device, but it increases security. So we've got a VM for everybody to think about as well. A physical firewall can be split into logical separate systems. We call a VSys. And if I had a hospital and I had maybe the dental college and then the pediatric college, and totally two different schools within the same complex is one way I've seen this used. I could create a VSys A, and Administrator Joe is in charge of all the rules and appropriate configurations for the dental college. Now that Administrator Joe has no administrative capability and access to the pediatric firewall. So multiple customers, multiple departments, because what we do is we separate and allocate the physical resources to these virtual systems. And that is a very important way to accommodate these type of specific environments. And so, boy, this is just a very interesting beginning. If you attend the training with us, or if you further research these topics, you're going to see that every one of these is a very expansive element that plays a role in the big picture of PAN-OS security. And I'm super excited you had a moment to share with me today, and I'm happy to answer any questions that you folks may have.
Hey, thank you so much, Ryan. That was awesome. Really appreciate you going through that with us. So apologize if you've already answered this, but what is zero trust micro segmentation?
My reference to zero trust would be, I'll use a specific example, and let me draw this because it's the easiest way to compare for me, especially with firewall administrators. I've worked with other firewalls that the users inside, when they go out and talk to the internet, we'll say this is the internet out here, all of this in here is considered trusted. So if I've got a user here that wants to go out to an external resource, a lot of firewalls will just consider that trustworthy and not apply individual in-depth analysis techniques. Now, certainly they would treat incoming traffic very differently. They assume that this is not trusted. But the zero trust factor incorporates this traffic as well in the deep dive analysis techniques. We treat everybody the same as far as the hosts on our network and all of the traffic. No matter where it originates, we consider it vulnerable and we apply our certain techniques. And that micro segmentation can give us a really good control of separating the HR department computers and the finance department computers. So even though they're all in one big happy family, we create these little mini zones, and that gives us that ability to do micro segmentation, and then we scan it all. Great question.
Yeah, fantastic. Manny, appreciate all the good questions coming in here from me. So zoning capabilities for visibility into internal traffic, is this risky or steps to protect the environment?
Definitely steps to protect it. Here's my example. One of my favorite features of, and great question, but one of my favorite features of PanOS is called DNS sinkhole. And I touched on it, but I want to go a little deeper with that. So here's my firewall, and then I've got a user, let's say his name is Tony, and he's back here, he's got a corporate PC. Now, as long as he's sitting in this network here, in, let's say, in Global Knowledge headquarters there in Cary, North Carolina, well, he's controlled and protected. But what if he takes that corporate laptop and he goes on a worldwide tour on a sailboat around the world? Now, while he's out of town, this PC is joined on every wireless network he comes anywhere near. Well, that's where we can run into problems. And so the firewall would not have any ability really to have control there. But let's say Tony gets infected with spyware. Unbeknownst to him, he comes back from vacation and he fires up his laptop there in the corporate environment. That spyware begins to try to call home. So when you were talking about this analysis, this would be super important to analyze the behavior of this computer. And one of our features called the anti-spyware profile has a DNS sinkhole mechanism. So if this was a call out to xyz.badsite.net, well, then our cloud-based intelligence says, oh, wait a minute, that's on the list. That's a malware site. So we would, instead of forwarding that DNS request, we intercept it. And it's, remember, this is a trusted internal asset. So the firewall then passes back what I call a fake address. And when we see, we create a rule, when we see Tony's PC try to get to that fake address, the logs tell us, and we know immediately we've got spyware communicating. So that's one example where internal analysis, in my mind, really sets us apart. Another super question.
Fantastic. And Ron, I want to be respectful of your time here, so maybe we'll take two more questions. Does that sound okay?
Absolutely, no worries.
Perfect. Okay, so does Palo Alto support APT protection and sandboxing?
PC protection, yes, we call that traps. Now, that's one area I'm not an expert in, but it is a widely used endpoint software. So definitely lots of information. If you research Palo Alto Networks traps, TRAPS. It's a software that resides on the PC everywhere that user goes. It's almost my analogy, which is not an expert analogy by any means. I would say that it's a little virtual firewall agent that's running on that PC, monitoring the activities and reporting back to some of those intelligence databases. And yes, sandboxing brings up the term, I think, of wildfire. If a user downloads a seemingly harmless file, maybe I send you a Dropbox link and you click on it and you download it. Well, we can, to protect ourselves, in the second, while the same second you're downloading that file, we forward a copy of it up to the sandbox, that wildfire cloud. I call it the mad scientists in the evil laboratory, and they'll analyze that file, and if indeed it presented any suspicious, malicious behaviors, well, we'll get what we call a verdict, and we'll be alerted that the user that downloaded that file has now got an infected file on their machine. So there's a lot of sandbox opportunities. That's one of them. And then, of course, that really does kind of explain, hopefully, what you're talking about for the endpoint protection, which is equally as important.
Perfect. Thank you, Ron. Last one here. Software as a service security can be achieved through what method?
We've got several components. First of all, our application ID database, Salesforce, you and I think of a website. The Palo Alto Networks Firewall has a dedicated signature. Imagine a string of ones and zeros that are always present in a certain location of the payload when a user is communicating with Salesforce. So we identify that communication. That SaaS tool to us is a fingerprint. And so we can report on it, we can track its activity, limit its activity, but every SaaS application, depends on, is it brand new, is it a well-known tool? Most of the SaaS tools that users are using today is known and identifiable by the in-depth inspection that PanOS provides. So that is kind of the one element on the firewall we use, but there's also these third-party tools like, again, Aperture, and that is a completely dedicated service monitoring SaaS application activity. Great question.
Fantastic. Yeah, hey, everyone, we really appreciate the questions. Wish we had more time. If you have additional questions, things that weren't answered, please hit us up on any of our social channels, Twitter, LinkedIn, Facebook, Instagram, whatever. Let's make our social team earn their money here. So, feel free to reach out to us and we can get answers to your questions. Thanks again, Ryan. I hope everyone enjoyed today's webinar. If you'd like to learn more about this topic, we recommend these courses here listed. If you would, use a webinar 25 or CA webinar 25 code, and that will get you 25% off your next Global Knowledge course. And finally, be sure to visit Global Knowledge's website to access additional free resources like technical articles, white papers, and webinars. I have seen a couple questions come through the chat asking about previous recordings and certificates. Almost every occasion so far that I've had this question come up, it's because folks have unsubscribed from GK emails. So check and make sure you're not unsubscribed. That could be the reason you're not getting them. Appreciate everyone being here today. Thank you so much. And Ryan, I can't say thank you enough. Fantastic presentation. Thank you.
Thanks, everybody, and have a great rest of your day.
Thanks. You too, Ryan. Everyone else have a great day.